Hello and welcome to this lesson on Avogadro's number and its significance in the mole concept. In today's lesson, we will understand the concept of Avogadro's number and appreciate its significance. So far, we've explored the concept of the mole, which is a fundamental unit in chemistry used to quantify the amount of a substance. Building on this foundation, today's lesson will enhance our understanding by introducing Avogadro's number. Understanding Avogadro's number unlocks a new level of comprehension in quantitative chemistry, linking the macroscopic quantities we observe and measure to the microscopic particles that make up matter. To understand the concept of Avogadro's number and its significance in the mole concept, let's delve into a few key points. Firstly, Avogadro's number is denoted as Na and is equal to 6.022 times 10 to the power of 23. This number represents the quantity of particles in 1 mole of any substance. These particles could be atoms, molecules, or ions. This means, regardless of whether you're dealing with atoms, molecules, or ions, 1 mole will always contain 6.022 times 10 to the 23 of these entities. You can think of Avogadro's number as a bridge between the macroscopic world, where we measure substances in grams or moles, and the microscopic world, where we count individual particles. This bridging concept allows chemists to work with quantities large enough to easily measure moles and grams, while still considering the individual particles involved. For example, if we consider 1 mole of water, H2O, it will contain 6.022 times 10 to the power of 23 water molecules. Similarly, 1 mole of chlorine ions will contain 6.022 times 10 to the power of 23 chloride ions, while 1 mole of carbon atoms will also contain 6.022 times 10 to the power of 23 carbon atoms. This is an extremely large number and is hard to comprehend. To put Avogadro's number into perspective, imagine having 1 mole of, or 6.022 times 10 to the 23 sand grains. This would be enough to cover the whole of England in a layer of sand 300 meters deep. Approximately the height of the Eiffel Tower. What makes Avogadro's number fundamentally important is its consistency. It doesn't matter what the substance is, be it water, carbon, chloride ions, or even something unusual like sand grains. 1 mole of any of these will always contain 6.022 times 10 to the 23 particles. This consistency helps chemists predict and measure reactions and quantities with great accuracy. Historically, this constant was derived as the number of carbon atoms in 12 grams of carbon-12. Let's dive into some GCSE level questions to apply our understanding of Avogadro's number and the mole concept. Our first question is an example of calculating the number of particles in a mole. How many molecules are there in 2 moles of water? Pause here to have a go yourself. Now, let's go through the answer. First, recall that 1 mole of water contains 6.022 times 10 to the 23 molecules of water. Since we have 2 moles, we need to multiply Avogadro's number by 2. This gives us the number of molecules is equal to 2 multiplied by 6.022 times 10 to the 23, which equals 1.204 4 times 10 to the 24 molecules of water. 2 now for our next example, involving ions. How many chloride ions are present in 0.5 moles of NaCl? Pause here to have a go yourself. Now let's go through the answer. First, recognize that 1 mole of NaCl contains 1 mole of positive sodium ions and 1 mole of negative chloride ions. Therefore, 1 mole of NaCl corresponds to 6.022 times 10 to the 23 chloride ions. For 0.5 moles, we use the same multiplication. The number of chloride ions equals 0.5, which is the number of moles, times 6.022 times 10 to the 23. This calculation gives the number of chloride ions as 3.011 times 10 to the 23. Now for our final example. In this case, we will be calculating the moles from the number of particles. If you have 1.2044 times 10 to the power of 24 atoms of carbon, how many moles of carbon do you have? Pause the video here to have a go. Now, let's go through the answer. We will start by using the relationship given by Avogadro's number. 1 mole of carbon contains 6.022 times 10 to the 23 atoms of carbon. To find the number of moles, we divide the number of atoms by Avogadro's number. Number of moles equals 1.2044 times 10 to the 24 divided by 6.022 times 10 to the 23. This calculation gives the number of moles is equal to 2 moles of carbon. So, if you have 1.2044 times 10 to the 24 atoms of carbon, you have 2 moles of carbon. These examples show how to use Avogadro's number to convert between moles and the number of particles, whether they are atoms, molecules, or ions. This understanding is crucial for solving quantitative chemistry problems accurately. So, who was Avogadro? Amedeo Avogadro was an Italian scientist born in 1776. Despite beginning his career in law, he later shifted to science, where his curiosity and intellect led him to groundbreaking discoveries. Avogadro was a professor of physics in Turin, and although his work initially faced skepticism, it eventually gained recognition for its importance. His legacy and groundbreaking law endures, and he is celebrated for his lasting impact on the understanding of molecular science. Today, Avogadro is remembered as one of the pioneers who laid the foundation for modern chemistry. In today's lesson, we delved into the concept of Avogadro's number and its pivotal role in the mole concept. We learned that 1 mole of any substance contains exactly 6.022 times 10 to the power of 23 particles, which can be atoms, molecules, or ions. We examined how this relationship holds consistently across different substances, allowing us to count particles by weighing them. By reinforcing the idea that the mole is a common unit for counting particles, we have laid the groundwork for more complex quantitative chemistry topics.